Hello there. Here I am again, Aguila at your service, and we will be learning mathematics my way. Okay, for today's tutorial, we will discuss how we are going to transform quadratic function into its vertex form and then vice versa. So here are the learning objectives for our tutorial video. First, we are going to identify the values of a, b, and c of the given quadratic function. So we can apply this one if we are going to use the vertex formula, because we will be getting the values of a, b, and c. And second, the main purpose of this tutorial, we are going to write the standard form of the quadratic function in the form f of x equals a, the quantity of x minus h squared, plus k, and vice versa. We are going to write the standard form into the vertex form and vertex form to standard form. So let us start. The standard form of the quadratic function can be written into its vertex form. I think you are familiar with the standard form. We have f of x equals ax squared plus bx plus c. So again, this is the standard form, and then the vertex form, f of x equals a times the quantity of x minus h squared plus k. So upon looking the two equations, we can see the difference. When it comes to the standard form, we have values such as a, b, and c. But when we go to the vertex form, we can see another letters or another variable such as h and k. So in transforming from standard to the vertex form, we can use the method completing the square. So this is one of the method when we solve quadratic equation, and then another way is using the formula for h and k or the vertex formula, and I prefer the second one. But in this tutorial video, I'm going to show to you the two methods on how we are going to transform standard to vertex form, and then vice versa. Okay, let us have our first example. So we are going to transform from the standard to the vertex form. So the technique in doing this one is you are just going to focus with the forms. Again, mathematics is the study of forms, and my way, I learned mathematics by focusing on the forms, because that especially on transforming any forms to another form. So we should focus on the forms. So given we have f of x equals 2x squared. I think if you were able to look at my previous video about quadratic function, representing quadratic function, you are familiar with this function. F of x equals 2x squared is one of the example of an incomplete quadratic function. Why I will say incomplete? Because in this case, the value of b is equal to 0, the value of c is equal to 0. So if the given function is just as simple as this, the solution is also very simple. So again, we focus with the form, and basically we are just going to follow. So we start with f of x, because we have f of x in our form. And then next we have equals, so we also have equals. And then if you are going to look at the vertex form, the next variable is a. So you ask yourselves, what is the value of a? What's the value of a? And it's very clear that the value of a is equal to 2. So we are just going to copy that one. So that's it. Next, you are going to have this part, x minus h squared. So the whole of this is the next step. The given, we only have x squared. So how are we going to write in this way? X minus h squared. And in fact, we don't know where this h is coming from. So you look at carefully what will be the next step. So what happens, instead of x squared, we rewrite that one as x minus 0 squared. Okay, if you are going to ask for the explanation why, you focus on this one, x minus 0. So x minus 0, what will be the answer? X minus 0 is equal to x. Any number subtracted by 0 is that number. So if we have x and then we square it, that is equal to x squared. And basically, that is x squared. So that's why instead of x squared, we rewrite that one as x minus 0 squared. Why? Because in this case, the value of h is equal to 0. And to continue, if you look at the given, we don't have any remaining terms, variables, or numbers. So naturally, in the vertex form, the continuation will be plus 0. Why? Again, if you look at the given, there is no remaining terms, numbers, or constants or variables. That's why it will imply that in this example, the value of k is also equal to 0. And that's it. So you look at the solution. That's very simple. Why? Because f of x equals 2x squared is just an incomplete function. Okay, let's proceed to the second example. F of x equals x squared plus 25. Again, this one is another incomplete quadratic function. Why? Because in this case, the value of b is equal to 0. That's why it's incomplete. So the same process, we are just going to focus with the form. So we copy f of x, and then equals, and then what is the value of a? So this time, if you are going to look at the function, I think you are very familiar with this. If you do not see any numerical coefficient before x squared, it's understood to be 1. So meaning the value of a is equal to 1. And since it is asking for the value of a, but since the value of a is equal to 1, it's understood that we are just going to write nothing. So instead of writing 1, we will not write 1. So it's understood that a is equal to 1. So we continue with the x minus h squared. So again, in this case, x minus h squared, it has something to do with these two terms. So you keep in mind that every time that the value of b is equal to 0, you go directly with this one, x minus 0 squared. Explanation was explained in the previous example. Again, keep in mind this one. Every time that the value of b is equal to 0, In this part, you are just going to do this method, x minus 0 squared. And then for the continuation, you will have to look at the value of the constant, which is positive 25. And in this example, what is the value of c, which is positive 25? Automatically, that will become the value of k. But take note, it will only happen again if the value of b is equal to 0. So again, if b is equal to 0, automatically the value of c will also become the value of k. Okay, so we will have the vertex form f of x equals x minus 0 squared plus 25, and again the value of a is equal to 1, and again we do not need to write 1. Why I can't erase? Again, we don't need to write 1. Okay, let's have our third example. F of x equals x squared plus x plus 1. So this time, if you are going to look at the given, it is a complete quadratic function. You have value for a, value for b, and the value of c. So the first thing I'm going to show to you is to transform this function into the vertex form using the method completing the square. So to do that, our f of x, we are going to change that one into y. So in my previous video, I also explained why we can change f of x into y, and then copy the equal sign. And then next, we will have x squared plus x. And what we are going to do is to group together. To group together terms containing x. So terms containing x are x squared and x. That's why I put a rounded rectangle, to show that I'm grouping them. And you look at what happened to one. What happened to one? It is spinning because it is feeling out of place, because these two are very sweet because they have common. So what will happen? One should be transposed on the other side so that it will not be feeling out of place. So again, when we are doing transposition, always remember the rule. Okay, so we will have y, and then when we transpose positive 1, if you can recall, when we do transposition, when we cross the equal sign, we are just going to bear in mind that we are going to do the reverse operation. And since the operation is addition, when we transpose on the other side, that will become subtraction. And then copy 1. And copy the remaining terms because we have nothing to do with it. In this method, in this step, we are just transposing 1 to the other side. Again, do not forget to change sign because that is one of the source of common mistakes of students. Next, after we are able to transpose 1 and it's not feeling out of place anymore, we are going to do to make a P is T. P is T. P is T. I think you are familiar with this. That is perfect square trinomial. P is T. P is T. X squared plus x. So how are we going to do that? We are going to add the third term, perfect square trinomial. That's why it's called trinomial, because we are going to add a third member so that it will become a perfect square trinomial. And how are we going to do that? We are just going to look at the numerical coefficient of x. Again, x, the numerical coefficient of x, not x squared, x. And since we do not see any number earlier, it's understood to be 1. So we are going to get that numerical coefficient, and then I will delete this one first. And then we are going to divide it by 2 always. So again, as recall, we are going to get the numerical coefficient of x and then always divide it by 2. Now we are going to have 1 divided by 2. So just a tip, if the answer is not a whole number, a fraction, then leave it as a fraction so that we will not experience any difficulty. So we are going to have 1/2. After dividing it by 2, you are going to square. So that's the process. Divide by 2 and then you square. And what is 1/2 squared? So that is 1 times 1, 2 times 2, so that is equal to 1/4. So this 1/4 is the term that we are looking for. So what we are going to do, we are going to add this one to make it the third term, and making this x squared plus x plus 1/4 a perfect square trinomial. So that is PST. So that's easy to remember. PST. PST. And then if you see this sign, that is an equal sign. So just imagine what you did earlier. What I did earlier is I'm adding 1/4. So meaning the sense of equality is now gone because I'm adding 1/4. So to maintain the sense of equality, what I added on this side should be also added to the other side on this side. That's why I'm going to add 1/4 also. Okay? Again, to maintain the sense of equality, you should do the same thing on both sides. That's the basic. And since we added 1/4 on this side, we should also add 1/4 on the other side. Now, next thing we are going to do is to simplify this one. -1 plus 1/4. -1 plus 1/4. I'll do it in this part. -1, I can write that one as -4/4. Let's do the wise way. Why I'm doing it 4/4? Because I saw that the next fraction is 1/4. So I need to make -1 into a similar fraction with 1/4. And since this is just -1, I know that 4 divided by 4 is equal to -1. That's why I can change -1 into -4/4 plus 1/4. Plus 1/4. Now we are going back to the elementary. And since they are similar fractions, then we can solve. -4 plus 1 is equal to -3. So that is equal to -3/4. So just copy the common denominator. Kids. So that will become y minus 3/4. And then copy the equal sign. And then after the P is T, we will have what we call as SOB. Just remember this how do we call this one? Abbreviations. From PST, we proceed to SOB. SOB means the square of binomial. So for you to understand, from perfect square trinomial, we are going to make it a square of binomial. And since we have the term square, we should have this one, a parenthesis and then a square. And then the remaining of binomial, so we expect that inside our parenthesis is a binomial. And how are we going to do that? To have the first term, just look at this one. If it's x squared, then just look at this one, the variable. Because since this is a perfect square trinomial, then this is also a perfect square, and the square root of x squared is x. So that will be the first term, the x. And then you look at the sign of the middle term. If it's plus, then the sign also of this binomial is positive. And then if it's minus or it's negative x or minus x, this is also minus. Again, that is your lesson during your grade 8, and I'm just refreshing it for you. Next is the last term. For the last term, it's very simple. If you are doing your solution, just go back to the number before you square when you have the perfect square trinomial, and this is that number. This is the number before we square, and then just copy that one. So you copy that one, so you are going to have 1/2. So again, x is coming from the square root of x squared, or just the variable. This is plus because this is plus, and 1/2 is coming from this number, the number that you, or the result when you divide it by 2. Or another way is the number before you square, and that's it. So you already have the square of binomial. And the next thing we're going to do is to go back on the form. The vertex form, it states f of x equals a times the quantity of x minus h squared plus k. So meaning we should have a value of a. We have the x minus h squared. So I think this one meets already this part. What we need is the k. So what we are going to do, since we are done with the square of binomial, we can now transpose back 3/4 to the other side. And this time I think it will not be filling out of place. So you will have y is equal to x plus 1/2 squared. I just copied, and then transpose negative 3/4 to the other side. Since this is subtraction, and when we do transposition, the opposite operation will be addition. So that's plus. And then 3/4. Okay. So if you are going to look at this one, the value of a is equal to 1. And we don't need to write that one. Since I wrote 8, I will delete. And then the only difference now is this is f of x and this is y. And since at the beginning we changed f of x into y, we can also do the reverse process. From y we change that to f of x. That's it. And then the magic rectangle, signifying that that is the final answer. And I'm going to delete it, delete this one, because you might interpret that as plus minus. Okay, so that's the process. It's long because I explained it thoroughly, but if you will be the one to do it, it is just short. So what you're just going to do is first group the terms containing x. So in other books, they will not transpose 1. They leave it here. But in my case, I prefer to transpose that constant so that we can focus on this side, and then it's very, I think I feel convenient doing this one. Okay, Let's have the other method. And this time we are going to use the vertex formula. And I said earlier that I prefer this method because with this method I can even do it mentally. So it's very nice actually. But I just presented the first method because each individual is unique. I don't know which one do you prefer. So for the vertex formula, we have h equals negative b over 2a. H, because that is one of the variables that we are looking for in the vertex form. Another variable is k. So k equals 4ac minus b squared over 4a. Now going back to the given, f of x equals x squared plus x plus 1. First thing we're going to do is to identify the values of a, b, and c. And I think you are expert in that. I also flashed the expected answer based on the previous slide. So this is the answer that we got on the previous slide. So expecting that we will also get the same answer. So first identify the values of a, b, and c. So a equals 1, b is equal to 1, and c is equal to 1. Next is to apply the formula. We are going to start with h. H equals negative b over 2a. In doing this, you are just going to be more careful with this part, the negative b, because sometimes if the value of b is negative, and then you are going to forget to write negative times negative, and that will make your answer wrong. So just follow the formula. We will have negative 1, so that's negative, and then the value of b is equal to 1, and then on the denominator we have 2 times 1, so that is 2 times a. Then continuing our solution, we have negative 1 is over 2 times 1 is equal to 2. So basically we cannot simplify this further. And I tell you earlier, I prefer fractions in lowest term, of course. So h is equal to negative 1 half. And you can see, yeah, they are related, 1 half. And in this case, it's negative 1 half. Maybe we are wrong, but I don't know. Maybe. Let's have k. Let's have the value of k first. 4ac minus b squared over 4a. You might be, because I experienced this in class, some of the students is asking why this is the formula or why it has to be like this. The answer is this vertex formula is also being derived using completing the square, and we are having this using this easily, diba? Because of their works on deriving this formula. So do not question why it's like this, because this is the formula. And if you're going to ask where these formulas came from, it is derived by using completing the square. And I think it's also on the modules or on your learner's material. So going back to the solution, we are going to substitute. We have 4 times 1 because a is equal to 1, times 1 again because c is equal to 1, minus 1 squared, and then over 4. So 4 times 1 times 1, that is equal to 4, minus 1. 4 minus 1 is equal to 3. My presentation is fast forward. And then 4 times 1 is equal to 4. And then since we cannot simplify it further, we have k is equal to 3/4. Now, to have this vertex form, we are just going to go back or to focus on the vertex form, which is the f of x equals a times x, the quantity of x minus h squared plus k. Now, we know that a is equal to 1, so we don't have a problem on this part. So we just copy f of x equals, again, a is equal to 1, x. We're going to follow the form again. Most of the students, or some na lang, some of the students commit mistakes on this part because they do not follow the form. The form states that x minus h. So you are going to write x minus h. So that is x minus, and what is h? H is equal to negative 1/2. So you need to write negative 1/2 because some of the students will just write 1/2 because you already have minus, and that is wrong. You are going to follow the form. That's why it should be x minus negative 1/2 squared plus 3/4. And then I would like to emphasize this one. It doesn't mean that since we have plus k, this is always plus. It will not follow like that. It will depend on the value of k. Now, if the value of k is negative, of course, this will also become minus. But since the value of our k is positive, then this is just plus. So now, from this part, if you are going to look at this, you interpret this one as negative times negative. That's the basic. Negative times negative, that's why it becomes positive. I will just erase because it might be mistaken as plus minus. So that is the reason why it becomes positive. And then that's it. You compare the two answers. Our answer on the previous slide and the answer on this slide. We got the same answer, meaning our solutions are correct. Now, it will, okay, it will be up to you on what method do you prefer. Okay? Next, one of our learning objectives is to transform vice versa. So from the vertex form to the standard form. And this is more simple, or this is simpler or simple. To transform from the vertex to the standard form, start by squaring the binomial and apply distributive property if possible. Because sometimes distributive property is not possible, especially if, it's possible, but it's useless if a is equal to 1. Okay, let's have our answer earlier. And we are going to transform it back to the standard form if we can get our problem earlier. So you have f of x equals x plus 1/2 squared plus 3/4. So the first thing we are going to do is to apply squaring the binomial, meaning we are going to evaluate this one, x plus 1/2 squared. We are going to squaring the binomial. So we are going to evaluate x plus 1 squared. And we are going to do the special product so that it will be fast. So for the special product, you are going to square the first term. First term is x, so that is x squared. Next is plus. This is plus because this is plus. And then that is always times 2. That is always times 2. For the special product times the two terms, 1/2 and x. And then I just put 1/2 and 2 side by side because we are going to simplify this one. But on this part, this is always 2, and we are just going to multiply the two terms. This is 2 and multiply the two terms plus the square of the last term. So what is the square of 1/2? 1/2 times 1/2, that is equal to 1/4. And then copy the remaining term. plus 3/4. Okay? Then next is to simplify what can be simplified. Again, that method or that step is squaring the binomial, and that is always the first step, square the binomial. Next is to simplify what can be simplified. So if we are going to look at this one, we can simplify this part. We can also simplify these two terms because they are both constants, and then we can multiply 2 by 1/2. So we will have f of x equals x squared plus what is 2 times 1/2, that is equal to 1, times x, that is 1x or x, plus 1/4 plus 3/4. Since we have similar fractions, we can just add the numerators. 1 plus 3 is equal to 4. 4 over 4 is equal to 1. And that's it. We were able to go back to the given standard form earlier. F of x equals x squared plus x plus 1. Okay. Let's solve our fourth example. And I told you earlier that I prefer the second method, the vertex formula, because again I can do it mentally. So in this tutorial video, I'm just going to use the vertex formula. So I'm going to identify the values of a, b, and c. A is equal to 4, b is equal to negative 40, and c is equal to 103. So you should know how to do this, because if you cannot do this part, then congratulations, you cannot solve or you cannot transform this function into its vertex form. But this is very basic. Next, we are going to use the formula h is equal to negative b over 2a, and what we are going to do is just substitute and simplify. So we have equals, and then our horizontal bar signifying the division, and then we follow the formula negative, and then we are asked for the value of b, and this is what I said earlier. And since b is negative 40, you write negative 40. Okay, and then for the denominator we have 2 times 4, that is 2 times a. And then for this one, again, if you can see or if you can encounter situations like this is just implying negative times negative, so that will be making positive 40. So negative times negative is positive and 40, and 2 times 4 is equal to 8. So some of the mistakes being committed by students is when they have 2 times 4, they will answer 6 because they are very excited to get the value. Always review your answers. Okay, 40 divided by 8 is equal to 5, and the magic square. 40 divided by 8 is equal to 5. Okay, next we have k equals 4ac minus b squared over 4a. We are just going to substitute and simplify. So we have 4 times a is 4, so that's 4 times 4. C is equal to 103. Wow. And then minus, so you write minus, and then b squared. If b is negative, enclose that one in parentheses, because if you will not enclose, you might make it positive before you square, and that's wrong. Enclose that one in parentheses, signifying that we are going to square it before performing subtraction. And then on the denominator we have 4 times 4 times a. Next is we are going to have 4 times 103. Again, using our mental calculator, that is equal to 1648, because 4 times 4 is 16. 103 is 100 plus 3. 100 plus 3. This is how you are going to do mental computation. You find ways you can do it simpler. 4 times 4 is 16. So 16 times 100, that is 1600. And 16 times 3 is 48. So 1600 plus 48 is 1648. That's mental calculation. And then minus negative 40 squared is 1600, because that is negative 4 times negative 4 is 16. And we're just going to add two zeros also from 40 times 40. And then on the denominator we have 4 times 4, which is 16. 1648 minus 1600 is equal to 48. And denominator 16. 48 divided by 16 is equal to 3. And that's it. Magic rectangle. Okay, I will erase this one first because it will destroy our beautiful work. Okay, we have, and since our goal is to transform this standard to the vertex form, after getting the values of h and k, we are going to focus with this form and just follow. F of x, copy. F of x, copy also equals. Yan. And then A, do not forget to go back to your values of A. Values. To your value of A. So A is equal to 4. And since A is equal to 4, obviously we are going to write 4. Different with our previous example because it's always 1. That's why we cannot see a number before the parentheses. Then just copy this one, the x minus h squared. So we write parentheses and the square. Then inside the parentheses, we start with x because that will not change. And then minus. That's always minus, x minus. Then h is equal to positive 5. So you will have x minus 5 squared. And then after that, just follow the form. You will have plus, and then k. K is equal to 3. So that's it. And then magic rectangle. So f of x equals 4 times x minus the quantity of x minus 5 squared plus 3. So that's our final answer. Okay, on the next slide, we are going to transform this one back to the standard form. So you remember the two forms. Okay. So this is this is our answer earlier. We are going to transform it back to its standard form. So again, I already showed to you how we are going to transform back to standard. It is always starting with squaring the binomial, and on this vertex form, this is the binomial that we are going to square. So you are going to square the binomial first. So copy of f of x equals, copy 4, just relax 4, and then squaring the binomial again and again. Squaring the binomial, we are going to use the special product. You are going to square the first term. First term is x, so that is x squared. And since this is minus, so this is also minus. Okay? And then always times 2. Times 2. And then multiply the two terms, 5 and x. Do not mind the sign anymore because it is already on this part. So the term, just the terms. And then the square of the last term. The square of 5 is 25. So this is always positive. The first term, this is also positive always. because we are squaring. So even if we square the negative, it will always be positive. The only difference between the two lies on this part, the sign of the middle term. And then copy the remaining term plus 3 because it might crime because it is being left alone. So we just copy it. Next, after squaring the binomial, we are not yet done with squaring the binomial. When you say square the binomial, we need to simplify this part. So you are going to have f of x equals 4, just relax 4, and then x squared. And what is 2 times 5 times x? 2 times 5 is 10, 10 times x is 10x, and then the minus, negative 10x, plus 25. Just copy, and then just copy again, positive 3. After squaring the binomial, the next step is you are going to apply the distributive property. Distributive property of multiplication over these terms. So since we have 4 on this part, we are going to apply distributive property, meaning multiply, multiply, and multiply. So you are going to have f of x equals, what is 4 times x squared? Basically, that is 4x squared. 4 times negative 10x is negative 40x. 4 times 25 is 100, and plus 3. We are going to take away the parentheses because the 3 wanted to go together with 100. So the next step is we are going to simplify, meaning combine like terms if we have like terms. And since we have two constants, we are going to combine 103. So we are going to have f of x equals 4x squared minus 40x plus 100 plus 3 is 103. And that's it. Magic rectangle. Okay, let's have our last example. Yes. F of x is equal to negative x squared minus 2x minus 3. And again, I prefer using the vertex formula, so I am going to identify the values of a, b, and c. A is equal to negative 1 because of this sign. This sign. Okay. B is equal to negative 2 and C is equal to negative 3. They are all negative. Why are you like that? You should be positive in life. Okay, they are all negative. H is equal to negative B over 2A. Just substitute and simplify. So you will have negative and be careful because B is negative 2. So you write negative 2. And on the denominator, you will have 2 times negative 1 because A is equal to negative 1. And simplifying further, negative times negative 2 is equal to positive 2. And 2 times negative 1 is equal to negative 2. And then positive divided by negative is equal to negative. That's why we are going to have h as negative 1. Magic square, rectangle there. Magic rectangle. Next, we are going to find the value of k. 4ac minus b squared all over 4a. So substitute, and simplify. So 4 times negative 1 times negative 3 minus, again, enclose b in a parenthesis if it's negative, so that we will not have confusions later. In the denominator, we have 4 times negative 1. 4 times negative 1 times negative 3, we have 2 negatives, so that will become positive, right? So 4 times negative 1 is negative 4 times negative 3 is positive 12 minus negative 2 squared is equal to 4. And on the denominator, we have 4 times negative 1 is negative 4. And simplifying it further, 12 minus 4 is equal to 8 over negative 4. And finally, we have k is equal to negative 2, magic rectangle. And since we already have the value of h and k, we can now write this function into its standard form following the form f of x equals, or a is negative 1. We don't need to write negative 1, just the negative sign, and that's okay. It's understood to be negative 1. And then the parenthesis and the square, so that inside it we can write x minus h. And the value of h is negative 1, so we write negative 1 plus k. We have plus k. But the value of k is negative 2. That's why it should be minus, because that's plus minus and that's negative. And 2. Negative 2. Okay? And again, we encounter again the negative times negative. So we are going to make it positive by just doing this. Okay, that's it. F of x equals negative times the quantity of x plus 1 squared minus 2. And finally, the vice versa. F of x equals negative times the quantity of x plus 1 squared minus 2. Again, the process is just the same. You start by squaring the binomial. So you will have f of x equals negative. So just stand by there, negative, because we are going to do this binomial first. Square the binomial, square the first term, so that is x squared. Since this is plus, you will also have plus, and then I will erase because it might be misunderstood as plus minus. Okay. So next is, that is always times 2. Times 2, times 1, times x, times 2. That is always times 2. And multiply the two terms. And then square the last term, which is 1. And then do not forget negative 2, so that it will not cry. So you will have, again, when we say squaring the binomial, it also means simplifying this part. So you are going to have f of x equals negative times x squared. Simplifying this one, we have 2 times 1 times x is 2x plus 1. And of course, the minus 2. After squaring the binomial, we will going to apply distributive property if possible. And in this case, it's very possible because we have value of a is not equal to 1 but negative 1. Again, we cannot, or we will not do distributing if the value of a is 1 because that is useless. But if it's negative 1, we need to apply distributive property. That's why f of x equals negative times positive x squared, that is negative x squared. Negative times positive 2x is negative 2x. And negative 1 times positive 1 is equal to negative 1. And then minus 2. And then you focus on this one because they are all constant terms. So they need to be simplified. That's why we're going to have f of x equals negative x squared minus 2x and negative 1 minus 2, since it's subtraction, so that we will have a longer time spending together going to show to you what's negative 1 minus 2. Negative 1 minus 2 is basically the same as negative 1. Instead of subtraction, you proceed to addition and then change the sign of the subtrahend. Since the subtrahend is positive, that will become negative 2. And since we are adding like signs, we are going to add and copy the common sign. 1 plus 2 is equal to 3. Common sign is negative, that's why it will become negative 3. Okay, magic rectangle. That's the final answer. Okay, thank you for watching. Thank you for spending your time with me. I'm very happy making it with you. So again, thank you for watching, and thank you because you will be watching this again. Bye bye.